Our task and mission is to work out the theta. So the first step we're going to do is work out the trig ratio, substitute it in there, and then once we discover which ratio it is, sine, cos, or perhaps tan, as we work it out, then we're going to get the answer and inverse or shift the sine or the cos or the tan, shift it, and come up with an answer where we're going to have degrees, decimal degrees. And then we're going to change the decimal degrees into degrees, minutes, seconds. There's a function on your calculator that turns it shift degrees, minutes, seconds. It'll turn into what you want, degrees, minutes, seconds. And then we're going to round it up to the nearest minute. Why? Because we have 60 seconds in a minute and 60 minutes in 1 degree. We're not talking about time, 60 minutes in an hour. We're talking about degrees. So degrees are broken up into what? Degrees, minutes, seconds. And the seconds we're going to take in this example and round them up into minutes. So let's do this example. First thing is to get the ratio. Let's write it up now. Well, there's the theta we're looking for. And the ratio will be, let's have a look at that 6 there. That's what's given to us. Whereabouts is that 6? Have a look. It's right next to it. Right next to the theta. That starts with an A. What is it? ADJ. It's adjacent. And right here, this long length, you probably already know. That is HYP. The long length or distance on the triangle is the hypotenuse. So let's write those ratios out. So the theta equals adjacent over hypotenuse. Okay, now let's work out adjacent over hypotenuse. Is it a sine? No. Is it a tan? No, it's a cos, isn't it? So let's put the cos in there. Cos theta equals adjacent over hypotenuse, and what does that equal? Well, it's 6 over 17, as we can see. So let's write that down, 6 over 17. Now, let's change this down here. Let's bring it down there. So we can say cos theta equals, now 6 divided by 17 on the calculator will give you a decimal. I like working with decimals. Some people like to leave it as fraction form in the calculator. You're welcome to do either way. Either option works. I prefer decimals. In this example, we're going to do decimals. 6 divided by 17 gives you a decimal of 0.353, rounded up to 3 decimal places. Now, what we want to do is get this theta all by itself individually. So let's do that. So the way to do that is to shift cos, inverse cos, or second function cons, depending on your calculator, and bring the cos over that side. So the theta becomes an individual by itself. So that equals cos, power minus 1 means shift or inverse, bracket, 0.353. 0.353. Cool. Now, let's go to the calculator again. And on the calculator, shifting cos 0.353, pressing the buttons in there, you will yield an answer in decimal form. So it will be degree in decimal form. So it'll be whole degrees of 69 degrees, 0.3327. Now you can also put the degree here if you wish. So it's 69.3327. There are no degrees, minutes, or seconds yet. So that's what we're going to do now. So let's do that. So we go now, shift degrees, minutes, seconds will give you degrees, minutes, seconds. By pressing that button, you will end up with 69 degrees, 19 minutes, and 57 seconds. This is what I was talking about earlier. Now, how do we round up or round down? Well, when we're talking about degrees and minutes and seconds, the seconds, when they're above 30, we round the minutes up by 1. So when they're above 30, when they're below 30, we keep the minutes as they are. Now, in this situation, isn't it true that we have seconds that are above 30? That's right, it's true. It's 57. That's way above 30. So this 19 will round up. So the angle, the missing theta, is theta equals 69 degrees. That's rounded up, so it becomes 20 minutes. And that's the answer, the missing pronumeral theta right over there.